How much do you know about trash? Not the basketball court kind, the real stuff. The mountains of plastic bottles, the rotting food scraps, the nuclear rods glowing quietly in their steel drums. Humanity generates 2.2 billion tons of solid waste every single year. That's the weight of 300,000 Eiffel Towers, and it's growing every second. Landfills are overflowing. Oceans are choking. We are running out of places to put it. So what if we aimed higher? What if we took every last piece of human garbage and threw it into a black hole? This is what if. And here's what would happen if all of human trash fell into a black hole. Before we start launching dumpsters into the cosmos, you need to know which black hole to use, because this choice could make or break the whole plan. The most common type is called a stellar black hole, formed when a massive star collapses under its own gravity. These are typically around 15 to 30 miles across and pack the mass of up to 20 suns into that tiny space. Sounds powerful enough to swallow our trash problem, right? That's the first bad news. The gravitational tidal forces near a small black hole are ferocious. The difference in pull between a point 1 mile away and 2 miles away is so extreme it would shred anything approaching it into long, thin strands. Scientists call this spaghettification. Your garbage containers, your compressed trash cubes, your drums of toxic waste, all spaghetti before they ever get close. So a stellar black hole is out. But don't cancel the mission just yet, because there's a better option. A supermassive black hole. These are the giants that anchor entire galaxies, and there's one right at the center of our own Milky Way. It's called Sagittarius A, and it contains the mass of 4 million suns. Near the event horizon of something this enormous, the tidal forces are actually gentle enough that your garbage would arrive completely intact. So that's the target. 165 quadrillion miles away, sitting at the heart of our galaxy. That's the trash can. Now, what actually happens when the garbage gets there? As the trash approaches Sagittarius A, it hits something it didn't expect, the accretion disk. Most black holes are surrounded by a swirling ring of gas and stellar debris spiraling slowly inward, and it is one of the most violent environments in the known universe. Temperatures inside reach tens of millions of degrees. The moment your garbage enters this disk, it gets caught in the chaos, compressed, and superheated. The plastic breaks down. The metal breaks down. The chemical compounds, the forever chemicals, the microplastics, the toxic sludge, all of it gets stripped apart at the molecular level until nothing remains but a fog of charged particles. In a strange way, the black hole has already solved the pollution problem before the trash even reaches the point of no return. But as the matter spirals closer to the event horizon, something even stranger begins to happen. Time slows down, not as a feeling, as a physical reality. This is one of the most tested predictions of Einstein's general relativity. Gravity warps space-time, and near a black hole, it warps it dramatically. If you were watching from a safe distance, you'd see your garbage approaching the event horizon and then gradually slowing, dimming, shifting red, until it appeared to freeze completely at the edge, never quite crossing over, fading into darkness. From the garbage's perspective, it crossed normally and is already inside. But you would never see that. You'd watch it hover at the threshold for what appears to be eternity. This is because at the event horizon, space and time swap roles. And the math of that swap means the outside universe sees the crossing last forever. Inside the event horizon, the trash has no choice but to fall toward the singularity, the infinitely dense point at the center where all our equations simply break down. We don't know what happens there. Nobody does. The garbage arrives, and then the physics we understand runs out. But here's the twist that Stephen Hawking discovered in 1974. Black holes aren't entirely black. They slowly leak energy through a process called Hawking radiation, caused by quantum effects at the edge of the event horizon. over timescales that make the current age of the universe look like a lunch break. A black hole gradually loses mass and eventually evaporates completely. And when it does, the question becomes, is the information about your garbage preserved in that radiation? Does some quantum fingerprint of every plastic bottle and banana peel survive, encoded in the dying glow of the black hole billions of years from now? This is called the black hole information paradox, and physicists are still arguing about it. If the answer is yes, your trash is truly gone as matter, but it lives on as information, written into the last light of a dying black hole in a universe so old every star has long burned out. So would throwing our trash into a black hole actually solve anything? The honest answer is that the journey there would take millions of years, cost more energy than civilization has ever produced, and still leave the garbage problem growing here on Earth in the meantime. But the thought experiment gives us something valuable anyway, a standard, a definition of truly gone, not buried, not moved, not floating in the ocean, converted, stripped to atoms in an accretion disk, swallowed by a singularity, dissolved across billions of years into radiation. That is what truly gone looks like. And nothing we currently do with our waste comes close. So the next time you throw something away and wonder where away actually is, think about Sagittarius A. Think about the accretion disk and the frozen image at the event horizon, and the Hawking radiation leaking back into a cold, dark universe. That is the distance between where our trash goes and where it would need to go to really disappear. Would you dare close that gap? Are you ready to think about what we leave behind? Very soon, we'll take you on your next hypothetical adventure.